Hello everyone, my name is Tiezhen Ma from South China University of Technology. I'm glad to be here to introduce our work, progressively generating better initial guesses towards next stages for high-quality human motion prediction. This is a joint work with Yongwei Nie, Chen Jianglong, Qin Zhang, and Guiqing Li. The human motion prediction problem aims to predict future human motion sequences based on the observed ones. It currently has many applications, such as intelligent driving, alarm detection, and animation generation. As a result, this problem has received a lot of attention in recent years. Early in the study, prime methods use recurrent neural network to model human motion. Because of the serialized nature, their prediction accuracy is significantly improved compared with non-deep learning methods, but they take a pose as a token, while ignore the structural information of the pose. Therefore, the subsequent approaches use GCN to model the human pose, but the original GCN still lacks the ability to handle spatial-temporal data. Our approach was inspired by the work of Wei Mao. We call it LTD for short. LTD designed a feed-forward network. Each block is consistent with original GCN. The most different is padding the unknown future part with the last frame of the known historical part. It guarantees the consistency of the input and output, and also allows the residual connection. More important, the padding can be seen as a good initial guess to improve the prediction. So we wondered, would the prediction accuracy be further improved by using a better initial guess? We designed an experiment to test the idea. We directly padding the input with the main value of GT. We speculate that with padding the GT information into the input, even though it's vague, it still contributes to the prediction. And here is the experiment result. We take LTT as baseline. From the fake, we can see that the prediction error gradually decreases as the length of the padded GT frames increase, which proves that our speculation is correct. However, in prediction, the GT is not available, so we designed a two-stage network. The first stage predicts a coarse initial guess, and the second stage makes a fine prediction. Finally, in our paper, this two-stage network is generalized to a multi-stage network. In our network, we start with building intermediate target for initial guess. Specifically, we use AAS, a smoothing strategy we proposed to smooth each trajectory in GT. Then, these intermediate targets are used to supervise the prediction result at each stage. By this means, each stage does prediction based on the initial guess of the previous stage. Each stage contains an encoder-decoder. Its basic component is GCL, which contains SD-GCN and TD-GCN. They have stronger spatial-temporal information extraction capability compared to the original GCN. We first introduce AAS, and followed by SD-GCN and TD-GCN. When given a human motion sequence, a trajectory is obtained by linking a joint at different moments. The original GT is smoothed by AAS as intermediate target. The specific formula is shown below, where the smoothed value of each joint is determined by the average of its historical motion. SD-GCN and TD-GCN are taken as a backbone. They all have a similar structure to the original GCN, consisting of an adjacency and a weight matrix. The SD-GCN deals with the pose in spatial dimension, and all poses share the same SD-GCN. TD-GCN deals with the trajectory in the temporal dimension, and all the trajectories share a TD-GCN. Compared with the original GCN, they have a stronger ability to capture spatial temporal information and a small increase in overhead. Following, we will show some experimental results. We evaluate the methods on human 3.6 m with mean per joint position error. As the table shows, our 3D error is much smaller than that of the prior method. Moreover, we measured prediction error at different action and joint. As you can see, we have a great advantage in complex action and the joint of the limbs. Here are the statistical results, and you can see from the red box that our predictions are closer to the GT. You can get the QR code and more information from the GitHub link. Finally, thank you for watching.